I'm starting with a little easy one because I have seen this problem in the morning itself and I already came up with a solution, but let's try to do it again. It's a little easy one, so I think it will be a good start. I haven't solved any single problem this entire month, so this goes to be my first one. The question says number of laser beams in a bank. It says that anti-theft security devices are activated inside a bank and you are given a zero indexed binary string array. So the very first problem uh, statement, or let's say the very first basic keyword that I found in this particular statement is this binary string array, right? And it is named as bank, which is representing the floor plan of the bank, and it's a m cross n 2D matrix. So fine, as an input I will be getting a matrix which is m cross n, and it's a matrix as an input to me. Pardon for my writing, as with the help of mouse you really can't expect much. Right, so every single location, the bank of I represents the ith row, so that is the first row, second row, third row, and so on. It contains either 0 or 1, right? So 0 means the cell is empty and 1 means the cell has a security device, right? Mostly in these kind of problems we are concerned with the values that have 1 in them. Okay, now there is one laser beam between any two security devices if both conditions are met. So these are the two conditions that I'm going to read. The two devices are located on two different rows, R1 and R2. For example, in this one, this is the first row, this is the second, the third, and the fourth one. It says that here this is a camera, let's say. So 1, 2, and 3 cameras are there. So if you have to go with the stringing of this particular array, it will be 0, 1, 1, 0, 0, 1, and it will be 0, 0, 0, 0, 0, so on. It will be 0, 1, 0, 1, and 0, 0. And the last is also 0, 0, 1, 0, 0, 0, and similarly something that they have written into their inputs as well. What we need to do is that this particular camera, when strikes the next camera in whatever row it is, it can be immediately to the next row, or it can be even after to the next one, or to the next one, doesn't matter. But in whichever it is, all you have to do is to simply make a connection, right? This light is connected to this light. This light is connected to this light. Similarly, this is connected to both of them. This is also connected to both of them. Then this chapter is over. Now you come up to the next one. Now these two will have only one light in common, so both of them will make their lines like this, right? So I think it's a very simple problem. If you have figured it out, it's very easy. Let's say that how are we going to attempt this one? I think it's a very simple one. And if we talk about the brute force solution, then it's pretty simple. Like, let's say I'm going to copy this particular image, and if I can paste it over here, yeah, it comes over here like this. Okay, cool. Now I'll try to paint over on this one. I'll use a different color to show the differences. I'll use green color, right? So what is happening is that this particular light and this particular light are in connection. So what we can do is we can go for one thing, and that is we have to select the rows in which there are lights first of all. So 1, 2, 3, and 4. So 2 doesn't has like any light in it, so we can simply ignore this one and we can create a new matrix in which we have only those kind of rows in which lights are present or these cameras are present, right? So we can just create this as 1, 1, 1. Then ignoring this one, we come back to this one. This is 1 and this is 1. And coming to the next one, this is 1. So these are the three rows in which we are worried about. And what we need to do is we just need to find the row which we are on and the next row. So just count how many ones are there in the next row for the first value, right? So this is the first value, and how many ones are there for it? 1 and 2. So add 2 to your answer. Then for this also you have these two values, 1 and 1. So 2, 2 again. Then for this one again you have these two values. So it will be plus 2 again. This will make it 2 plus 2 plus 2, that is equals to 6, right? For the first row. Then you come up to this one, and for this it is 1 and this is also 1. And that's all. So 6 plus 2 will give us the final answer, which is 8. And 8 is our final answer. But there is a repetitive step in this. I mean, this is the brute force in which you will count for each one and you will eliminate the rows where you haven't got any. It comes to multiplication problem. Instead of counting these 1 and 1 for every single one that is present in the previous row, I can just simply take a count of it, 3. here 2, and here 1. So we are multiplying 3 into 2 plus 2 into 1. That's all. That is all what we're doing, right? So how good it will be an idea. And now I'm using the second figure now. So let's look over to the second figure only, and I'll use a different color this time. Just take the count 3, 2, and 1, and that's all. This is my new row. This is the final row in which I have to work. This is the final array, let's say. Let's make it a, or we can use a stack also if you would like to use a stack. Doesn't matter, right? You can use any one data structure in which you can put up these particular values. It can be an array, it can be a stack, it can be a queue, it can be anything. But the most simplest one has to be an array. So if we go like this, we just simply need to return the multiplications of these particular values. So it is as simple as that, right? So let's start coding with this. So what are our steps, right? We have to be very clear with what kind of steps that we are following. So the very first step is pretty straightforward, and that is to uh, take only, let's say, those rows in which ones are present. So that is the first thing. Right? The second is then count ones of each row and store it somewhere. And here we will use an array for the purpose, right? And then the third one is just take adjacent products and add them up, right? Isn't this what we actually have to do? So this is it. This is exactly what we need to do. So now this is my algorithm. So whenever I'm going for an interview or any such thing, I just need to tell this that these are my steps, and this is the most optimal one, right? This is the most optimal one. What is the time and space complexity that you're going to utilize before actually coding? So that can be done very simply, right? M cross n is the size of the matrix, and you need to go through each row every single time. You need to do that, right? So in the worst case, if there is one single one present at the very bottom of the row, at the last cell, let's say, you need to travel through all the given cells in the matrix. So M cross n is definitely going to be your time complexity, right? And as soon as you take count of each row, either you have two options. What you can do is you can first create this dummy array, right, or the secondary array, and after creating this particular array, you once again iterate in the same array. Now there are m rows, right? So the size of the array is at max m, right? So this is your space complexity. So the maximum space complexity you are going to hit is big O of m, and the maximum time complexity you're going to hit is big O of m cross n. If you are iterating on the array, like the third step says that take adjacent products and add them up, you are going to use one variable called as like int maximum or int answer, whatever it is that you're going to return actually. That is a part of the answer, doesn't matter, it's a constant variable. Sorry, not constant variable, it's a variable, but it's of constant size of 1, so it doesn't matter on your answer. For the time, if you are still asked to further optimize it, what you can do is you can go for uh, not reiterating onto your dummy array or your secondary array, right? You can calculate it straight away. As soon as you have a value, you store it in a variable and move ahead. Whenever you have another value, take the product, add it into the answer, and copy the current row count into the previous row count, and make the current row count as 0 again, and keep on doing this again and again. So because of this, you will have only two variables instead of maintaining an entire array. But that is too optimized. That is the final level in which can you cannot further optimize that particular thing. For time, it's gonna be O of m cross n, that is for sure. Nothing beats it. Nothing has a chance of coming closer to it, right? Whatever method you try, whatever hit and trial method you try, but in the worst case possible also, m cross n is going to be your time complexity. And space complexity, you can optimize the space complexity for a given interview, right? But let's go with a not let's not immediately jump to the most optimal solution. Let's just go for the most basic one, the one we just discussed, and it's going to be very simple, I'm telling you. So first of all, let's create an int answer, because that's the first thing that we'll be doing. 0 is going to be the minimum value to it, right? Because it can't be negative. If there are no ones, 0 is the answer. So I'm just going with the most basic one, right? I will create a vector. Let's say it's a secondary or a dummy or an arbitrary array or helper array, whatever it is. So I'll just call it as AR, or let's call it V as vector. Now what I'm going to do is I'm going to create a counter variable, int count equals to 0. Now this is my reusable variable for each and every row of the string that I'm going to have, right? So that's how it will happen. I will just simply create an iterator. I mean, I think you're familiar with this over bank. I will have an iterator over the bank. And now this particular iterator will point to every individual string, like the very first one, like IT is currently this particular string, right? So this is the particular string that I will be having. Um, or if you are like confused, like how we will be proceeding towards using this iterator concept, if you want to look over the internet, it's totally all right. If you want, let's go with the basic one because that will provide us with more clarity. So bang.size I++, it's a very basic replacement of what I just wrote. And then again, of course, you will have another for loop. This is the jth loop, which will go inside each and every cell. This is the n one, right? The above one is m, like the number of rows actually. Now we are stepping into each cell, that is via the number of columns. And j will be less than bank of I, whatever it is, dot size. So now this will let us go into more details into the cells, right? So if now bank of, let's say, I and j. Now what it is, it's a character, right? It's a character. Bank of I and j is simply a character. And now this particular character needs to be 1. So you just can say this as 1. I mean, character can be 0, character can be 1. And it's not a true or false Boolean value for which you can simply leave that if bank of I, j. You have to mention it equals to 1. And it's a character, it's not a string. So you can like use just this one single operation and you can just increase the counter, right? Just increase the counter. And as soon as you have done with one's particular cell, uh, you just, you know, what would you do here is, let me see one thing. This is the count plus plus, like 0, 1, 2, and 3. So 3 is already done. So as soon as you get out of this particular loop, in your answer, you're going to add, like, okay, we can add a condition also before actually pushing it into V, right? And that is that if count has exceeded 0, that means it is not 0 anymore, then you will do two things. First thing is that you are going to push it into the vector v dot push back what count. Okay, and doing so, you have to reduce count back to 0 because you want to refresh the particular variable to be used again. Now when you come out, you just have to keep one check, like one basic check, that if of course v dot size is equals to 0 maybe, or 1 maybe, right? Or so overall it's less than 2, and you simply return what? 0. That's all. So if v is not created, there are no values in the vector, or if there is only one value in the vector, right, the answer has to be 0. As you can see this particular example, it's not connecting with anyone, right? So whatever the value of count be, let it be entire m, entire n, whatever it is, doesn't matter. Next thing is that you will go with a for loop now, and that will start from 0. It will go all the way to v dot size, and it will be I plus. This is the second iteration actually. Now this second iteration is actually an extra step that we are doing. If you are going into the most optimal code, you don't need even to do this. But since we are doing it completely as let's say not the most optimal approach, but one of the best approaches, then we will be doing this iteration again to keep a clarity on the answer, right? So what you will do is you just need to be very easy with this one. You just need to run it one lesser than the last value. Why? Because it will be very clear now that answer actually what we created into our int answer is nothing but plus v of I multiplied by v of I plus 1. That means the next particular given element. So you cannot go to the very last element, because then this will go out of bounds, which is not expected, and simply return the answer. Now there can be some overflow cases which we will try to handle. Right now I'm not just thinking about anything. I'm just thinking about running this particular code, and the case one is running fine. These are some small cases. These will work fine. I'll see if any like overflow cases are there. If there are overflow cases, I'll have to correct my code. And it gives me, okay, so it's done actually. I didn't thought that I just thought that there would be some edge cases that would you know uh, create some issues here. Okay, now this is like a runtime which actually beats on the current server in which you're running the code. It is very different. Like if I submit the same code, like you do remember these values, right? It's 12% and this is 68%. Let me submit it again. I mean, I'm just doing it to show or prove a point. So now this time when I do it, like there are no cuts, right? Yeah, so see, it's 25 now at 54. So it's a very different kind of a number every single time. Sometimes it shows like what, 90%, then it drops to 50, then again 80. So a lot of things happens. If you look at the complexity analysis that we did, it is big O of, right, m cross n, which is correct. And space also is pretty simple. It is nothing but big O of m, right? So that's the number of rows at max. So we have already done it in a very optimal manner. One of the best solutions that people have solved it is definitely, why are not using the second iteration and why are not using a secondary array. But I have used it to keep it very, beginner friendly. You can really try doing it. um, let's try to optimize it and like more further in terms of memory, and in terms of just one iteration to get the answer. I want you guys to do it on your own, and whatever solution you come up with, which is even more better than this, put it up on the comment section there. What I'll do is that I'll simply check that what you guys are coming up with. If I find any better code, I'll definitely pin it to the top. And like this, we can grow our community, and like this, we can really hustle together. This is mostly for me actually, and I also want, since I'm coding sidewise, so I want you guys to also be involved into my coding journey. You may learn few things out of me. I hope my first video wasn't that boring. I'll open all these more challenges questions and I'll check whether they are good or not, and probably we might use them for our next videos. Thank you so much, guys. I really appreciate if you like this one and maybe follow or subscribe me, whatever button that you see out there instead of dislike. Yeah. So thank you, everyone.